Video, we want to practice using some of the forms of factoring that we've discussed in the previous videos. So, quick review. We have talked about factoring out a common factor. And we have talked about looking for the difference of squares. And finally, we looked at perfect squares. So now let's look at a few examples that use all three of these techniques for factoring. And when we say factoring, we're talking about integer factoring. So all of the numbers involved will be integers. So let us begin with this example. So let's consider x squared minus 16. Go ahead and see if you can apply the appropriate technique to this expression. Okay, so the solution for this one involves simply recognizing that x squared is a perfect square and 16 is 4 squared, so we have the difference of two squares. So we can easily write this out as the product of x plus 4 times x minus 4. And if you're not certain, you can redistribute that, and you'll see that the inner terms plus 4x and minus 4x will cancel out. So the next example we want to look at is 2x squared minus 12. So the first thing you should check is common factors, and then look for difference of squares, and then perfect squares, and then we'll teach you other techniques beyond that. So when you look at this one, you should first note that there is a 2 times the x squared, and 2 is in fact a factor of 12. So we can rewrite this as 2 times the quantity x squared minus 6. Now when you look at the x squared minus 6 part of this, x squared is a perfect square, but 6 is not. So it's clearly not the difference of squares. And since there's no middle term, it can't be a perfect square. Therefore, we are finished for now. So this must be the most factored form that we can have. So 2 times the quantity x squared minus 6. Let's look at a slightly more difficult one. Let's look at 3x squared minus 12. Let's go ahead and see if you can figure out what to do with this one. Okay, so what I would do is always check for common factors first. There's a 3 times the x squared, and 3 is a factor of 12. So you want to factor out a 3 from each term. And when you factor 3 out of 12, you have a 4. And now this one's slightly more complicated because there's something else you can do. Hopefully you noticed x squared is a perfect square and 4 is the perfect square of 2. So we can break the second factor that's in quantity in the inside of the parentheses into 2 factors. So I can rewrite this as 3 times the difference of x plus 2 and x minus 2. Now that is fully factored. So note that we factored out the common factor first, and that made it clear that we had a difference of squares remaining, and we were able to take it to completion. So let me clear these out and give you a few more examples to work through. Okay, so the next example that we will look at is x squared minus 8x plus 16. So see what you can do with that one. Okay, so the way I would approach this problem is, first of all, when it's just x squared, there are no factors besides 1, so you can't factor out a common factor. There is a middle term, so of the techniques that we've covered so far, only a perfect squared would work. So let's see what this could be a perfect squared of. Since 16 is 4 squared, we can see that when we write this out, we could write that this is equal to x. Now be careful. It has to be minus 4 times minus 4. The reason that we know it's minus 4 is because when we multiply through the middle terms, we have to get negative 8x. And so we couldn't have x plus 4 times x plus 4 because that would give us a positive middle term. We can rewrite this as the perfect square of x minus 4. So also note in this problem, 8 is 2 times 4, and 16 is 4 squared. So this is going to work out perfectly, and because of the minus sign on the middle term, you must have an x minus 4 twice, which gives us the final answer, which can be written in more compact form as the quantity x minus 4 squared. The next example is 4 times x squared plus 12x plus 9. So let's see if we can factor this expression. Okay, so for my solution, I would note that 4x squared is in fact a perfect square. It would have factors of 4 and 2. 12 does have a factor of 4 or 2 in it, but 9 does not. So I can't factor anything out. But I've noticed, as I've noted already, 4x squared is the square of 2x. And 9 is clearly the square root of 3. Okay, and if I were to multiply 3 times 2x and then double it, I would in fact get the middle term. So this is a perfect square. So let's go ahead and figure out what we would use. It would be 2x twice. Since the middle term is positive, I know that it'll be positive, and I have to get the square of 3 for the last term. And when I distribute, I'll have a 6x and a 6x for my middle terms, and those would add up to 12x. So this is in fact a perfect squared, which could be written as the quantity 2x plus 3 squared. Continuing on to a final example, 3x squared minus 12x plus 12. Pause the video and see if you can work this one out. Okay, so the first thing I would notice is there's a 3, a 12, and a 12. All of those have a factor of 3. So let's start by factoring 3 out of the entire quantity. If you divide 3 out of the first term, you're left with x squared. If you divide 3 out of the second term, you have 4x. And if you divide 3 out of the last term, you have a 4. Now let's determine if this could be a perfect square. Obviously, x squared is a perfect square. 4 is a perfect square root of 2. And with the middle term also being a 4, if we were to take twice the perfect square root of 2 times the coefficient of 1 squared in front of the x squared, we would end up getting a 4. So this one will work out. Don't forget to rewrite the 3. Because what we're doing now is factoring the quantity in parentheses, and that part is a perfect square. Obviously, we have to have an x squared, and we have to have a 2 squared to get the first term and last term, and then we have to determine, because the middle term is negative, we need to have a minus sign in between them, and to just double check, minus 2x and minus 2x would give me the negative 4x I was looking for. So this, in fact, is the most factored form of the original expression.